Hi, in this video we'll be doing the analysis or demonstrating the analysis regarding the fitting of some of the important algorithms like linear discriminant, caret, knn, support vector and random forest, which are very much used as far as the classification problems are concerned. When I say classification, that means the target variable is discrete or a categorical in nature. It is not a continuous in nature. For that, we'll be using two libraries, library caret and kernlab, since caret is highly recommended for this kind of fitting. And for that, we'll be using a data set where we have different locations. It's a soil data. We have different locations: Benihama, Shalimar, Vadura. Then we have another location, that is Shohama, and the last one is Rangil. So we have a categorical response, study variable, response value, and we have some continuous, and based on these we want to fit the algorithms and see which of the algorithm is best in terms of accuracy and kappa. And for that we'll be utilizing a 10-folded cross validation. This is very highly recommended cross validation in if we take the examples of 80-20 or 70-30. This is gives much better results or the more reliable results. And for that we'll be utilizing this machine learning, this ML data. And in order to fit all these algorithms, what we will do, the first thing is that we'll see the labels of our data set, that is ML. And then what we will do, we'll first utilize, or we can say first we have to you have to set the cross validation. That is we'll be using this k-folded cross validation, where which will split our data set into 10 parts, and we'll be using this process or repeating this process 3 times, so that in an effort to get a more accurate estimate. So for that we'll be use this default code, that is trainControl, and the methods will be CV, and there will be 10 folds. So 9 will be in train and 1 will be in test, and similarly the iterations will go on. So we'll click on this, run. Then we want the matrices in terms of accuracy and kappa as well. So in order to fit the first one, we will set the random set.seed, which is used for random number generation. Is an integer vector containing the random numbers, and which are very much required when you are doing a certain kind of cross validation. Then we will fit the first algorithm. Say for example, we'll give a name to a function, fit.lda is equal to our assignment operator. This is the default code train, and within this we will write the locations, which is our target variable, locations, then tilde dot comma. This is the shortcut for this fitting, because we don't need to write the names of all these variables. We will simply use the shortcut, that is our study variable response, then followed by tilde dot comma. Then we will write the name of the data. The name of data in this case is ML. Then the method, since we want to fit linear discriminant analysis, for that we have a default name for that, or code or a function. Then we want the matrices in terms of accuracy and kappa. Then what we want to do, we will use this default train.control, which is equal to control here. This is for cross validation. Then we will fit. So we have fitted the first algorithm. Now we want to fit the second one. For that we will simply replace this method. Suppose we want to fit the caret. For that we have to use this rpart, and here we will give a name to this also. We will write it as caret. Okay. Then after that we want to fit the knn. Here the method is very important, because these are the default things which are available in R, and you have to be very cautious while choosing the method. Then here we will write knn. Then after that knn we want to fit the support vector machine, but for support vector machine you have to use the radial method. Here we will write this svm. Then the final one, we will write or fit very important algorithm, that is random forest, and for that the method is by default rf, and the name which will give it, that is rf. Now we have not written the inverted commas here, that is why this plus sign got popped up. So we have fitted all these. Now what we will do, we want to combine the results of all these. That means I don't want to get the output of each and every fitted algorithm separately. For that I will use a function. Say for example, I will give a name to this. Say for example, I will write results is equal to resample. Okay, resample is a very good procedure for collation and visualization also, or collection, analyzing and visualization of set of the samples. So we want to combine all this, then we will write list. Then after that, within this list, what we will do, in order to save the time, what we will do, we'll simply copy paste this thing. Since we have already written all these codes, then put them here. Okay, since we are giving this fit.lda as a name LDA, since we have already written this function, so we will click on this enter. So all the results will be displayed in a one go, so that we can compare all these algorithms in a very quick time. So we will simply use summary, and within this summary we will write results. So there we have got the results in terms of accuracy as well as in terms of kappa. Since these two are very much used to test the performance of these classification algorithms, and the higher the value of this accuracy or this kappa is, or more towards the one in terms of kappa, that algorithm is considered to be more accurate. Since the accuracy is nothing, it is the ratio of correctly predict instance to the total instance, and accuracy is easy to understand and it gives the overall correctness of the model. Now as far the kappa is concerned, it's a statistics that measures the agreement between observed and expected classification. This is actually the ratio of two things. That means the correct classification, correctly predicted instance upon the total instance, and here it is nothing, it is the difference between observed and expected divided by 1 minus expected. This is actually the formula. If kappa value close to 1 indicates high agreement. So in this case, support vector machine is performing good in both these instances. So we want to get a dot plot for this. We will simply write dot plot, and within that we will write the name which we have given to this. So we'll be having a plot like this, where you can easily find which of the algorithm is performing better in comparison to the rest of the algorithms. Since in our case, support vector machine and random forest, including these are more accurate in terms of accuracy as well as kappa. So we can visualize this also, and we can get the print of these algorithms one by one. Suppose if I will write print, then I will write fit.lda or any algorithm. So we will have the results for accuracy and kappa, and if I will write svm here, we'll be having the values for this. And similarly, if we'll write this rf, so we'll be having this for random forest, then knn and caret also. So similarly we can get the results separately, but here we have used this resample function so that these all results will get combined, and we can easily take a decision which of the algorithm is accurately fitted on this model. since these algorithms are nothing, these are some kind of a codes which can be in the mathematical form or a computer code, which a data science or a data analysts used to study, analyze, or comprehend some of the complex data sets. And these kind of algorithms highly used when you have a huge data set. The data size of the data is very huge, and you are dealing with classification or regression problem, because the accuracy of these algorithms are considered to be good. They give good accurate, and the problems of overestimation and underestimation or overfitting or underfitting are usually overcome by these algorithms, machine learning algorithms. So this was a video, a simple and a short video about the fitting of some of the important algorithms. So we'll make another video regarding its fitting on another or different types of data sets, where we'll be focusing more on the data visualization part. Hope you will like this video. Thank you very much.